Okay. So this is going to be just an overview of what I'm planning next week for SNRS. So how many of you guys are going to SNRS? Are you going? Irene? Okay. I know y'all aren't. It's a nursing conference, which is where we'll be next week. Vicky's going to be here. I haven't heard yet whether she's going to host class or what she's going to do. If she does host class, it'll be something like almost like an extra session, and then we're going to figure out how to do a makeup session later. Anyway, and my workshop at SNRS is actually going to be 3 hours, and I was originally going to go until 4 o'clock, but my son leaves today on a school trip right after school, so my plan is to try to bug out of here a little bit after 3 so I can get home, see him before he leaves anyway. So it's a mom thing, I'm sorry. A couple more years, he won't care. He'll be driving himself, so anyway. All right. So I'm going to just dive in and we'll see how it goes. As we go, please stop me, raise your hand. Feel free to give me feedback. That said, so I know since all of y'all are in the class, I know you've all got R&R Studio installed and you all have GitHub accounts. Were you able to download or take a look at the materials that I had put out on GitHub? And if you didn't, that's okay. So one of the things that I'm going to be thinking through is, for now, we have great connectivity. Next week, I'll be in the Atlanta Sheraton, and they tell me I'll have Wi-Fi, but I'm fully expecting that for whatever reason, the workshops will stick me in some room in the basement with no Wi-Fi and really horrible cell phone connectivity. So I'm trying to think ahead on what I can do in case everything just, goes dark and I need to do it without connectivity. So we'll see. Yes. So Jennifer Lampier just sent me the list. I think there's like 9 or 10. So not bad. There's a lot of other really fantastic workshops at the same time. So, I know actually for the graduate students, there's like a graduate student one that's really good. Is that with Farron Epps? Yeah, and he's really good. In some ways, I'd rather go to his workshop. So anyway, okay. So the focus of this workshop is on reproducible research. So I'm going to talk a little bit about the background of that and workflow, sort of workflow pipeline, as well as workflow practices and principles that are a good idea to follow. The focus is on using R&R Studio, and you'll see why. Those are open source and free. And we're going to specifically look at some things, a little tiny bit of analysis, but the focus of this workshop is not on learning how to code in R so much, and there's very little statistics, but it's really on the documentation and dissemination pieces. So I'm going to show you how to take data plus code plus document and put them all together in sort of one package so that everything's connected. For example, and you guys have heard me talk about this. How many times have you written a report and then realized, oh, wait, we need to go back and remove these 10 subjects? Or you have a report template that you're working on and it's partway through the project and, 3 months from now you've got another 20 subjects and you want to update the report. So have you run into that in the past? And then to sit down and recreate, so you've got to recreate your analysis. You've got an updated data file. You've got to recreate the analysis. Then what do you got to do? You got to recreate all your tables and all your graphs again, and we've got to take all of that. We've got to cut and paste it over into the new document. We've got to reformat everything. Wouldn't it be awesome if you only had to do that one time? I'm not personally there in my own workflow yet, but I'm close on a couple of projects with the idea that once this whole template and sort of infrastructure is put together, then as the data updates, or even if your data doesn't update. So for example, I know a couple of you guys are working in the microbiome. Suppose you go through and the first time you run it, you get one set of analyses. And then you go back and decide there are things in the algorithm you want to change, like there's option settings. Like you decide, okay, instead of doing version A, I'm going to do version B. And you want to make that comparison. Then all you have to do is just change out that one section of the code, and the rest of the report will write itself. So, so that's the focus of what I'm going to do in the workshop. All right, so the outline, since I'm going to have 3 hours, this is my thought, and I don't quite have this completely ironed out, so like I said, you guys are kind of guinea pigs today. But I'm going to break it roughly into 30-minute modules, about 6 modules, with a break of approximately 10 minutes in the middle. We'll play that by ear. I'll kind of wait and see how things are going once I get down to SNRS. But roughly the first part, I'm going to give you guys some background and history on reproducible research, just to give you some context and why this is important. And then we'll go through the materials for the workshop and just sort of getting you up to speed, because I know I'm going to have people in the audience that have never used R and never used RStudio before, and kind of getting them started with that. And then before the break, give you a chance to actually write some R code, get a feel for sort of how R works and how to manipulate data. And then after the break, I'm going to focus on the documentation pieces. Specifically, I'm going to teach R Markdown, and you'll see how that works. And then we're going to create a document. And then at the very end, before you leave, we're going to talk a little bit about how to take that basic document infrastructure and turn it into a template that you can use for either repeating it in the future, making small modifications, and sort of automating that documentation process. All right, so reproducible research. And right now I have 45 slides. This is going to get cut down. I just haven't had a chance to cut it down. So this part might go a little quick. So just to give you some timeline and background, the term reproducible research has been around for more than 20 years. Depending on who you look at, a lot of people say that John Clarabout is the one who actually coined this term in his book, Earth Soundings Analysis, Process versus Inversion, or Process versus Inversion. Don't ask me to explain what that is. He's a geoscientist, but he's sort of given credit for this term. And I know a lot of you guys are familiar with the consort statement in looking at the standards for reporting in clinical trials, and this also helps to support the idea of being able to replicate or reproduce research. So there are some standards in conducting these trials, so they're comparable. Then in 2004, the International Committee of Medical Journal Editors said they would not publish a clinical trial that had not been registered. So you obviously have seen a lot of that in the last sort of 10, 15 years with the goal that basically it doesn't matter whether your clinical trial was quote-unquote successful or not, but it needs to be registered so that we have an accurate accounting of all the research that's going on. How many of you guys have heard of the term publication bias? Right? So, or in your own analyses, if you ever run an analysis and your p-value is 0.07, and you're like, darn it, I was really hoping for a significant result. That said, it's still data, it's still information. Even if your clinical trial was quote-unquote not successful, or maybe we didn't see a difference between the groups, or maybe the intervention wasn't as effective as you originally hoped or intended, that's still valid and good. You still did good science, right? And people should know about it. So that's kind of the goal. And then this paper here is one of the most touted, most referenced papers by John Ioannidis on why most published research findings are false. And if you haven't read that article, I really encourage you to read it. It sort of gives some good context. It sort of helps to set up the whole idea of probability of false alarms and false positives, and why, to a certain extent, why you can't always replicate things. An interesting presentation I saw a few years back, they were talking about a thing where they were growing bacterial cultures, right? And so they had them in the oven, and they were, they I guess incubate over a certain amount of time. And this one lab published their results, and they had found some really fascinating stuff. And don't ask me the study because I don't remember. But a few years later, somebody tried to replicate what they were doing, and try as they might. And they followed, the guys had published their protocol. They had exactly what they had done in the lab. They had the temperature settings, the length of time of incubation, all of that. And this other lab followed that meticulously, could not reproduce their results. Finally, they went back to the original lab and started working. It turned out that the actual oven they were using, even though the dial on the oven said something, let's say 150 degrees, well, the top left of the oven was about 120. The bottom right of the oven was 175. So it wasn't exactly 150. So How many of you guys at home, when you bake, like either set your oven a little bit hotter or a little bit colder because you know your oven and you know how it works, right? I do that. So there's some of this stuff that it's not so much that research findings are false. It's not like fraud. But it's that science is just really hard. So, you know, we have the best of intentions. Even if we publish and try to meticulously record everything we're doing, we're probably not really recording everything we're doing. And we may or may not know all the exact conditions that are ongoing. Some other things, these are good things to look at. There's some stuff out there from the FDA, not FAA, sorry, FDA. The Journal of Biostatistics is probably one of the most progressive in this area in pushing the idea of reproducible research. They actually now have 3 different markings that you can get when you publish in the Journal of Biostatistics. You can get a D, which means that your data is available, which is where most journals are really headed right now. And the NIH is requiring that you have a data sharing policy at the end of your study. So it's really kind of where a lot of people are headed. Then the next level of marking is, I think it's C, which means that your data and the code that you use to do the analysis are available. The final one, which is kind of the gold star from the Journal of Biostatistics, is a marking of R, which means not only was your data and code available, but that the editors at the Journal of Biostatistics were able to run your code with your data and reproduce all of the results exactly as they're presented in the paper, and so then you get the gold star that this is a truly reproducible manuscript. This article that was published in 2011 is also really interesting. It talks about the low percentage of researchers who actually satisfy the policies of a given journal for the availability and sharing of their data. So a lot of people do say, yeah, my data is available. And have you guys, anybody in here ever sent a request to somebody for their data? A, did you get it? And B, was it in a form that you could use and understand? Probably not, right? Not without lots of back and forth phone calls, or was it pretty decent? Yeah. So it's hard, and there are more standards and policies coming down the pike on how exactly. So there's places like Dryad and Figshare, and there's PLOS is very proactive in data sharing and stuff. So anyhow, so this is all ongoing. How many of you guys have heard about this study that happened at Duke, between Duke and MD Anderson? If you haven't read these, the links are here. There's a fantastic video. This is about an hour, a little over an hour long. Great presentation by Keith Baggerly on exactly everything that happened. But basically, Keith Baggerly and Kevin Coombs at MD Anderson, cancer researchers, they were really interested in what Duke had been publishing. Specifically, it was by Dr. Anil Patti, cancer researcher at Duke. They had written about genomic tests that they developed to look at the molecular traits of cancerous tumor and figure out which chemotherapy would work best. So they were basically matching chemotherapy to cancer type. They were doing sort of matching. They are personalized medicine, if you will, tailoring the therapies to the genetics of the type of cancer. And so MD Anderson, they were very interested, and they asked for a copy of the data. Well, they got it. Duke shared their stuff. They probably regret it now, but they shared everything with MD Anderson. And, of course, the first thing MD Anderson tried to do was sit down and run through the results and see if they could get the same answers. You know, data plus code, do I get the same thing? And they started getting errors, and they started not being able to match stuff up. Well, there were a couple things that happened, one of which was really, really simple. And I apologize now if I get this, say it exactly wrong, but there was something about the way the code was reading in the data, and it made some assumptions about whether that data file had a header row. So a lot of times in Excel especially, that first row is usually the name of the variable, right? And when you bring data into a computer program, sometimes it'll prompt you and say, does it have a header row, yes or no? And however the code was written, it made one assumption and the data didn't have that. So what was happening was when they read in the data, everything was off by one row. So do you think the cancer therapy types were being matched correctly? No. So that was part one. The other part was, as they got further into it, it wasn't just simple human error. There was actually systemic problems in that Duke group, the biggest of which was actually outright fraud. There's some stuff. Dr. Anil Patti is in big trouble. I think he faked his CV. There was a whole bunch of other stuff that happened too. But that said, just the human error. I mean, I've done that. And made an assumption when I read in a file and realized, wait, there's a bunch of errors. Why is this not working? And, oh, okay, it doesn't have a header row. So, by the way, any of you guys in here use REDCap? So when you go into REDCap and export data, you can actually export it out in Excel. If you do that, it will provide a header row for all the variable field names. But when you bring it and you export it out, say for SPSS or SAS, you get the program, the actual code to import the data, but the Excel file that comes along with it does not have a header row because the variable information is contained inside the SAS program or the Stata or SPSS program that reads in the data, but it strips out that header row. So if you're not really looking at what you're doing and like you just randomly export Excel and then later come back and pull the SPSS code, it won't work, and that's part of the reason. Anyway, so I encourage you guys to take a look at this. There's been multiple retractions that Duke has had to do, and there's ongoing lawsuits and all kinds of stuff. Another one that's really famous, and I think this one's sort of fascinating from a economics politics perspective, if you haven't heard of this, is the Rogoff-Reinhardt blunder. So these are guys that were at, I think originally Harvard, and there was a student, I'm going to pull this up since we've got a minute. Yeah, so Rogoff and Reinhardt, it was a widely cited paper about public debt and economic growth in a whole bunch of different countries. And let's see, where's the student? I was trying to find. I'll have to write this down. Anyway, but the bottom line was a student requested the data. Sorry, let me go back to my slides. And let's see, do I have, no, okay. Anyway, so there was a student at, I think, University of Massachusetts or somewhere, and he was doing an economics paper or for like a project for his one of his classes in college, and professor said, well, why don't, you know, this paper was just published, maybe you can get a copy of their data and just see if you can reproduce their results. So he did. So he wrote to them, and the guys were like, yeah, sure, it's published. Here's our data. So he sent them the spreadsheet. I'll have to see if I can find a picture of the spreadsheet for SNRS. And in the spreadsheet, you know, there was like formulas and stuff, and so when he started looking at the formulas, they had selected, so let's say there were like 80 rows, so 80 different countries. When they ran their analysis, they had only selected like the first 40. They never went back and updated the spreadsheet, I guess, once they got additional data. And so the paper, when it was published, was misrepresented because it was based on these assumptions about all of the countries that should have been included in the analysis but weren't. So some big countries like Canada, Europe, with lots of debt, but also experience high economic growth. Anyway, so there were some things, and it was a graduate student who found it. So see, you guys have power. You can rock the world. And it is. It's called the Excel error heard around the world. So again, it's this idea of being able to really sort of be able to see under the hood what's going on, what data is being used, how are the calculations being made, so that we can really understand the conclusions that are being drawn. There's some other stuff here. I probably won't go through all of these. Just know if you're interested in this arena, some things to keep in mind is the Center for Open Science and the Open Science Framework. If you've never taken a look, you ought to take a look at what they're doing with registered studies where people are making a concerted effort worldwide to make sure that, you know, like you may have somebody in Europe, somebody in Asia, and somebody in, I don't know, Canada, let's say, and they're all running the same kind of study, or they're all trying to replicate each other's work to try to figure out, okay, why is this replication not working, or what are the variables that we need to be considering? Just a few years ago, NIH actually published their guidelines for reproducibility. In 2015, the Open Science Collaboration, which is part of this whole Center for Open Science, they were actually only able to truly replicate between a third and a half of over 100 registered studies. And I think that number's been updated since then. Right.
So whether you've done an assay wrong or measured your blood pressure wrong, that doesn't, we're not even,
well, and so there's a little bit, and I wasn't going to do too much on the workshop on this, but there's a slight difference between replication and reproducibility. Depending on who you ask, it can go either way. But what I'm focusing on in the workshop is saying, okay, we've got data and we've got code. And I run it and get these results. If I hand you my data and my code, do you get the same results? In theory, that should always work, but you can have software differences, you can have platform differences. I mean, obviously, we've got a mixture of PC and Mac in here, and we know they operate slightly differently. Replicability is, say, Erin does a study, and then I go and do the study with, maybe she's got 100 participants, I have 100 participants. Do we reach the same conclusions? So hopefully we're both following the same protocol. But even then, it gets that's what they're actually trying to do. They're truly replicating the whole study and then comparing the results, which that gets at what John Yanidis was talking about with why so many things are quote-unquote false. This is another one that was just published in 2016, so it's about a year and a half ago, in Genome Biology. And this is sort of specific to biology, but it turns out Microsoft Excel, which is kind of a worldwide de facto for doing a lot of analysis, data manipulation, data sharing. But it turns out when you leave the default setting on, gene names get converted to dates and floating point numbers. I don't know if I have another slide on this. I'll have to go back and add it. I'll pull up the article. So, for example, gene symbols SEPT2, which stands for septin2, and March1, which is short for membrane-associated ring finger, they get converted to September 2nd and March 1st. They get converted to dates. So you're going along thinking you're processing a gene name, and Microsoft Excel thinks it's a date. So, and there's been some other things like that where, you know, you've really got to understand what your software is doing to your data. You can't just assume that it's leaving the data alone. And sometimes these, especially Microsoft, but it's not just Microsoft, a lot of the programs that we use are a little too smart for their own good. As a quick example, how many of you guys have ever cut and pasted either off of a website or out of a PDF file or even Microsoft Word, and you paste it in to, say, SAS code or R or something else, and you get an error, and you're like, but it looks fine. It's because there's all of this formatting and sort of hidden characters and stuff that cause problems. The one that drives me bananas are quote marks, so you can get smart quotes. So to fix that, one of the things you can do is cut and paste into like Notepad, a very vanilla, it's just plain text, and then take the plain text and bring it in, and it'll strip out all of that formatting. And that's basically what's happening here. And then there's just some other things here that talk about the number of papers and which journals they've been published in. It's fascinating, probably because just the sheer volume that Nature publishes, but close to 30% that were published in 2005 to 2015 had errors due to this problem. That's not trivial. So it's interesting. All right, some people to know, and I'll probably shorten this when I get to the workshop. Victoria Stodden is, she's actually a lawyer, so she talks a lot about reproducibility and data sharing and the ins and outs of that from a sort of a legal perspective, not just copyright, but intellectual property and so forth. Roger Ping has really taken the lead, and I got excited about this after I took his Coursera course 3 years ago, learning R Markdown and so forth. He's also the associate editor for reproducible research at the Journal of Biostatistics, and he's written a number of books that are really good. This book on implementing reproducible research, if you want to read further, is a fantastic book and has a lot of different case studies. It's not just all programming. I mean, it really talks about the science of reproducible research. Well, I've already mentioned John Ioannidis. Christopher Ganrud is another one. He's at Harvard, and he has a really good book that focuses specifically on the topic of this workshop, looking at using R&R Studio to support reproducible research. Another person just to know is Yui Ji. He's a software engineer at RStudio, but he's basically the one who wrote the knitter package that you guys are actually going to be using when we do the examples. And he's also got a really good book related to that talks about dynamic documents with R and knitter. And he's got a couple of other books out there as well. I'm going to show this. Frederick Leash, the only reason I bring him up, I mean, he's since retired. I think he's still living, or maybe it's Frederick Leish. Do you guys know, is it Leash or Leish? I've never known exactly how to pronounce it. I think it may be Leish. He was the developer of Sweeve. So part of what I'm going to show you guys today, I was talking about taking the data plus the code plus the documentation and putting it all together. That sort of falls in this category of what's called literate programming or dynamic documentation. And he's the developer of a package called Sweeve that actually merged together code, I think it was Pascal code, with LaTeX, which is an open source document development package. And I'll say some more about him. Anyway, here's some of the books. Some of this I may just move into a handout for the participants. Literate programming, the original term literate programming goes back about the same time as John Clairvaux in '92 coining the term reproducible research. But Donald Knuth is known as sort of the father of literate programming, and it's this idea of we're not writing code for a computer to understand with sort of comments. You know, if you've taken a classic computer programming class, first thing you do is teach how to program, and then you add comments as you go just so people can understand what you're doing in your code, like namely yourself 3 weeks from now, and you're like, what? Why was I writing this? But they kind of turned it on its head a little bit and said, no, what we need to be doing is writing documentations that humans can understand, but that has an interface to the computer. So it's really more the focus on the documentation with the code that's inserted and that helps explain what you're doing, as opposed to just writing code with documentation added later. So that's kind of and then Sweeve was like a follow-on to that. Some other things, I'm going to skip these for now. Here's a quote from Donald Knuth. His original program was called Web, and he was using TeX typesetting with the Pascal programming language. So this was in about 1981. And sort of Web, there's a few others out there that are follow-ons. I'll probably delete that slide. And then in early 2000, Frederick Leash came out with Sweeve. And Sweeve combined R code inside LaTeX documents. Turns out, actually, for those of you that use SAS, there's actually SAS Sweeve. There actually is a version of this that allows you to embed SAS inside LaTeX document writing. And the piece here that I want to point out is that once you've got everything put together and you've got the code tied to the document, things are created on the fly and inserted as you go. We're going to be using R Markdown and not LaTeX to create the document because it's a heck of a lot easier than learning LaTeX. But it's this idea that once everything's in place, things can be automatically updated if your data changes or if you decide to change the analysis code, and that allows for this idea of truly reproducible research. And the other pieces that are coming down the pike, too, are ways to sort of encapsulate the whole environment. So you guys haven't seen it yet in 741, but toward the end of the semester, we're going to talk a little bit about Amazon Web Services. So for those of you kind of doing big data, people talk about crunching big data in the cloud, but there's more to it than that, in that How many of you guys have ever heard of VMs, virtual machines? And in a way, we sort of have that, right? I think almost has everybody in here ever logged in to the virtual desktop system next door in School of Public Health? Well, when you log in over there, you're logging into a big server farm, and they can like massively handle all these different people logging in at the same time. But when you open that up, even if you're on a Mac or even if you were on a LaTeX computer, running LaTeX, or not LaTeX, sorry, Linux, when that loads, you're in a virtual Windows environment. So even if your computer's not Windows, when you're logged into that system, you're running like a Windows emulation. As far as the server is concerned, it's Windows. So one of the things that's really neat about this whole concept is it's not just that you're taking your data, your code, and everything lying together, but we can actually now encapsulate it inside these virtual machines so that you can control the platform, what version's being run, the number of processors, all that stuff. So that if that truly happens, then yeah, if I were to take my stuff and hand it off to Erin, she could log in and we would be working in the same environment, even though she has a Mac and I have a PC. So from a team science, how many of you guys went to Betsy's talk the other day on team science? I know y'all didn't, but anyway, here in nursing, that's hugely important, is that everybody's kind of on the same page. A couple other things, and you guys will see this as we go through. This is sort of the next evolution of Sweeve. UEG came out with Knitter, which combines R and R Markdown together, and you guys will see this in the workshop part. And we're going to talk about R Markdown. This extended it so that we can now write and easily publish documents on the web, so you can go straight to HTML as well as other formats. And a few years ago, this would have been a bigger deal, because when you installed all this stuff, you would have had to have also installed Pandoc to be able to convert from a Markdown environment to HTML, to Microsoft Word, to PDF, to be able to convert between all these different document formats. But it turns out now when you install RStudio, this comes along with it. So Pandoc is actually under the hood allowing you to create all these different document formats without you having to actually write code for Pandoc. So when that finally happened, I was in my office jumping up and down. I was all excited because then I didn't have to learn Pandoc. Again, I may put this on a handout. Pandoc's often called the Swiss Army knife of converting files. So just to give you a rough idea, if you have a file in any of these formats, you want to convert it to any of the other formats, that's what Pandoc does. Okay, so here I'm going to be teaching you guys how to use RStudio. So R is at the sort of the center hub, or RStudio here, and you're going to be creating documents using R Markdown. And when you're finished, you can create any of these ancillary products. So you could go to PDF, you could create an HTML web page, you could create a Microsoft Word document. I'm going to also show you guys how to make some slides. We won't have time in the workshop to do it, but if you understand the basics, you can easily begin to create like website type dashboards. You could actually create a book. You could create a blog. So it's incredibly powerful. All right, and some of this I'm going to skip through. These are just some key rules for reproducible research. Some of the things to point out here, I'm going to briefly mention version control, since all of you guys have been in my class. You sort of heard all that with Git and GitHub. There's some things here. Basically, always store your raw data. How many times have you made a plot? A few months later, somebody asks you, oh, we really need to update this label, or could you highlight this data point in the graph? And you go back and you're like, how did I make that plot again? Wait, was it version 1 of the data? Did I make it with version 2? So it's always a good idea to make sure that you kind of have the data and the plot together so that you know how those things were created. Same thing with tables. Any kind of presentation or summary of your data, you should have the code there somewhere to remember how you did that. And then there's a few other things. This idea of tying textual statements to the underlying results, that's sort of the cornerstone of what I'm going to show you in the examples. So standard practices. So these are the things that I'm hoping you'll take away from today. Like, what do you want to automate? What could you reuse to make your life easier? Like code, files, formatting. I can't tell you. People will ask me and say, can you update this report? We've added 5 people. And I'm like, yeah, sure. The analysis will take an hour. It's going to take me 2 days to reformat the 80-page report. So graphics, logo, header, boilerplate. So, for example, several of the studies we work on here, they have some fantastic boilerplate. We have a letterhead. We may probably even sometimes have like a special logo designed for the study. Wouldn't it be nice to just go ahead and incorporate that in our report templates? What do you want to be able to share with your team? What do you find yourself doing over and over, over and over and over? Correcting or reformatting. Think ahead. And if you won the lottery today and left your job or your position, or you graduate, what do you need to tell your replacement so they can pick up where you left off, as opposed to, bye, have fun figuring it out? But it's this idea of the continuity, because no man's an island. We're all technically part of a team. And I would even say, even if you really were just a single person doing your own research, you set it down and you come back to it 3 days, 3 weeks, 3 months later. Do you remember everything you were doing when you left? I know I don't. And I'm trying to get better about documenting my own stuff, but when you're in that like last minute crunch, the abstract's got to get out the next day, you got to get the poster to the printer, and you're scrambling and you're just cutting and pasting, you're reformatting on the fly, and then you come back to it later and you sit down to actually write the manuscript and you're like, why did I do this? So journalism, this is not way bigger than just science. 538.com, I really like their stuff. They've, at least in the past, here recently they just got bought by ESPN. So they used to be a standalone thing. They wrote a lot of stuff on politics and popular culture, and huge, obviously, during Obama's elections, but in general, all the presidential big national elections, they've always got good polling and presentations going on. But most of their articles provide references and links to the original data sources. And they actually have their own, they have their own GitHub site, but then out of that, we're going to work with some of the data sets from articles that have been published by 538, and there's now an R package out there called 538 that maybe doesn't have every single data set for every single article, but has a lot of them. And then you can actually work with those data sets to try to see, could you reproduce the results that were presented in the original journal articles. Andrew Flowers used to work for them. He was an independent journalist with them, and he has a great presentation on finding and telling stories with data using R. And this was at the RStudio conference last year in 2017. So I encourage you to take a look at that too, because that's a very interesting compelling presentation of sort of how to use all this stuff, and it's not just in science. We've already talked about Journal of Biostatistics and how they publish things. This one article right here, and if you don't remember anything else from my presentation today, go look this up. This blew me away, and this is actually in that integrating reproducible or implementing reproducible research that's written by Victoria Stodden, Frederick Leish, and Roger Peng in that book. And I was reading it, and it was just a little blurb, like a paragraph at the end of one of the chapters. So in 2001, there was an outbreak of E. coli, really virulent and deadly. It killed 50 people in Europe. And researchers at this Bainum Genomics Institute was working in collaboration with the Medical Center in Hamburg, Eppendorf, to sequence the genome. And given the severity of this outbreak and how fast it was moving, they announced and released the genome via Twitter to the worldwide community of microbial genomicists. As soon as that happened, what did they do? They set up a GitHub repository for everybody to collaborate, and they crowdsourced the analysis and the research. People started contributing in under 24 hours. And within 5 days, they had a bacterial agent proposed to kill the pathogen. So there's way more to the story, and I encourage you to read it. But that, I was just in shock. I was like, this right here is one of the reasons I'm so excited, and it's a bit of a soapbox for me when I talk about open source and reproducible research and stuff. This is the power. I mean, you can literally save people's lives. So, and this is, I think, truly going to become the norm of how we work in the future. It's one of the reasons why actually the whole, like R and Python for that matter, Python's also open source, those environments are rapidly, they're growing faster, and in some cases they're exceeding and beating the commercial companies out there, because the commercial companies are just not maneuverable enough. Microsoft has figured it out. Microsoft has bought in. They actually now have a whole open source division working with the R community, and they've bought into it. So, but like, and even SAS is moving towards some open platform kinds of things. So I think that's the wave of the future, is being able to collaborate and crowdsource, truly. All right, documentation, and you guys are going to see this, but this is sort of goes without saying. This may go in a handout. Keep your projects organized. Let's see, I'm going to just flip through some of these. Like I said, I had way too many slides. Automation, we won't talk a lot about that. Okay, dissemination. So we've already talked a little bit about the requirement, honestly, now to be able to provide your data and share it upon request. But it's a good idea to have it, even if it's only just for your future reference. Sometimes there's expectations by your funding agency, whoever you're publishing, increased visibility. I should highlight this, that if you do that, you are the source, so you become, by default, the subject matter expert. So it's a great way to get the visibility. Speed of collaboration, which we just saw with the E. coli example, and there's a lot of goodwill with the community and the public. Ways to disseminate, again, I mean, I do all of this. Here's some examples. Let's see, what else? Stakeholders. Again, some of this I may put in a handout. Okay, big picture. So you guys have probably seen me talk about this before. The RStudio software that you guys installed is a true integrated development environment. So it's a great way to interface to the R programming language, which you're going to get a chance to see. And I probably need to draw some little gray lines out to the side because the focus here is on R. But it turns out now through RStudio, you can actually use this interface to look at documentation and a little bit of code development, even with Python, C++, and I have a feeling more languages will come on board. So it's becoming, even though it's called RStudio with the original focus on R, it's becoming a little bit of a programming language sort of like interface, regardless of which language you're actually writing code in. The biggest contribution in this focus of the workshop is going to be on the dynamic documentation piece. And then there's some other stuff here with Git and GitHub, which when I do the workshop at SNRS, I'm going to mention briefly, but that's not the focus. You guys know it just because you took the class. All right. Okay. So that's, I know, a bit long. I'm going to shorten it, so because I want to get that into about a 30-minute block of time. Any feedback, any quick thoughts on that? Things you like, things you didn't like, got too long-winded? Okay. Just
a little bit overwhelming. I think I'm just
okay.
about the nursing, like who
the audience
is going to be.
Yeah.
And the Excel stuff is scary because so many things come via Excel.
Well, that one I think is important.
I think if you were to focus. Like cut down on some of maybe the bigger stuff and focus on how, like, as we get data files in Excel, how we can maybe check them or
that's a good point.
run them or look at them.
I'll admit, the point that they made there about the under default settings, right now I couldn't tell you how to fix it because I've never worked with gene data. So, but yeah, the fact that it reformats those things, I think there's a way to turn it off. I just have to look up. Sadly, I'm not an Excel expert. But yeah, that's a really good point.
So much, I mean, microbiome data, metabolomics data, those labs give us that in Excel.
Right. Okay, that's good to know. All right, so I am going to send this out, and I'm going to be updating the page here. So this is the GitHub repository that I put together for SNRS, and I'm going to be updating it between now and next Wednesday. So what you guys are seeing is just a rough draft. Sorry. With the goal that I'm going to put the content broken into these 6 modules, and I may go back and I don't know if I'm just going to call them module 1 to 6 or if I'm actually going to put a title in here. I'll figure that out. And I'm going to clean this up just to put a little bit more good information on the README page so that people can easily see what's in here, especially if you've never seen GitHub before. Yeah, I just need to go back and update the labels. Good point. Labels. No, this is good. Keep just shouting them out. I'm going to write them down. So a couple of things, just so for the people in the audience that have never seen GitHub, to a certain extent, GitHub is a web page. It has the ability to be able to look at content and information through a web browser. But more importantly, it truly is a repository for file, code, data sharing. It's a little bit like Dropbox or Google Drive, Microsoft OneDrive, any of those, Emory Box, etc. And the reason that it's called GitHub is not only is it a hub for these repositories of files and projects, but it actually uses Git under the hood. And Git is an open source software package for doing version control. And just to give you a quick taste of what version control means, assuming that we have internet connectivity, I'll be able to demonstrate this live. If not, I'm making myself a note here that I need to videotape this portion, and I may be able to play it back during the session if I actually am in the basement of the hotel with no internet connection. So to give you an example, in Module 2, this was some stuff I was working on last night, there's an R script file here that if I click on this file, I can view the R code, and you guys are going to see this in just a minute. But notice there's these buttons up here. It says raw, blame, and history. If I click on blame, it will actually show me that 5 hours ago, there was some stuff that I was doing here, and there was additional pieces that I was updating, and then I said I updated module content, and here's some things that I did to the file, and so forth. So to a certain extent, you can kind of see what I was doing each time I made changes. So that's one aspect of version control. I can actually click on history here and see who made changes. Right now, I'm the only one making changes, but it's possible that like 2 or 3, if I invited you guys, and actually this is a public repository, so you guys could do this. Suppose that you had downloaded this file and you had made changes to the R code, and you sent it to me and said, do you accept these changes? And I said yes. Then I would be able to see that maybe Melinda made these changes 5 hours ago, but let's say Irene had sent me stuff and we made changes and updates 3 hours ago, and it was contributed by Irene. So again, this idea of team science, we can see who's doing what changes were made, and so forth. So just a little taste of version control without having to get where you're emailing files back and forth, and it's like, version 2 with the date, your initials, this is the last file. No, this is really the final file. You know, with the 80,000 emails. Wait, do I have the last version? Did you have the last version? Okay, if we just do it all in the same place, then we can all see what's going on. So just a quick taste of version control. The other thing is that I am sending this out to all of my participants probably the end of this week, first of next week, with some read ahead on how they need to get set up with the instructions that they can clone or download this. And I'm going to assume going in that probably most of the people in the audience won't have GitHub accounts. If you do have a GitHub account, you can actually click the fork button up here and put a copy of my repository in your own GitHub account, and then you'll just have it. And if you guys remind me later, I'll try to show you guys in class that as I make changes, how to take those changes and update your own copy. We can talk about that later, but yeah.
Are you going to be expecting them to follow along or do this with you? And if
Maybe. If I can, I mean, I'll get into the workshop room as soon as I can and get set up. I'm not quite sure. I mean, I know there are workshops going on that morning, and then there's a lunch break, and then there's a series of workshops that start at 12:30. Mine's in that time block. So, yeah. I just want students to get frustrated if they right. Well, and that's the other thing, too, is as I finish up and finalize all of my notes, I'm going to have it very clear where they can go and just download the PDFs. So worst case scenario, like they don't have their computer, they couldn't get the software installed ahead of time, and they just want to sit there and listen, they'll have all the notes. And I'm hoping that maybe at the end of the workshop, anybody, I probably have a little bit of time one-on-one just to talk through it. So we'll see how it goes. I just want to make sure that people feel like they leave with material and content, even if they can't run it live. So we'll see how that goes. I'm fully expecting people to walk in and just sit there and listen. Well, I mean, you know, so, and if you can follow along, great. Good point, though. But for the people that don't have GitHub accounts, you can actually download this entire repository as a zip file and unpack it on your own computer, and then you'll have a copy of all of the materials and files, the code and so forth. Okay, so little introduction to GitHub. So, assuming that you have installed R and that you've got RStudio installed, go ahead and open RStudio. And when you do, I'm going to actually, let's see, let me close. I'm going to close this project. Hold on. Let me just close some stuff out here. I'll try to make sure that this is all clean and ready to go when I do the workshop next week. Broom. Yes. Okay. So when you open RStudio, your system is going to look a little bit different than mine. If nothing else, I'm running Windows. You guys may have a Mac or another kind of operating system, and your version may not be exactly the same. The current version of R is 3.4.3, which shows up here. So if you have something close to that, you should be fine. If you don't have exactly that, that's okay. And the current version of RStudio that I'm running, which you can see under the Help button up here, if you click About RStudio, I'm running version 1.1423. So your version of RStudio may be slightly different than that. If it's close to that, then everything should look at least similar. And then I'll ask, does anybody's look majorly different? At least give me a heads up. Question? No? Okay, sorry. All right, so when you first open this up, there's sort of some key components inside the RStudio interface. First of all is this window here is the console window. And this is sort of if you had not installed RStudio. Let's suppose you just installed the basic R software. When you open up the icon or you run the R program, you would essentially get just the console with the idea that you're going to be typing code in and that's it. You're basically running everything from a command line. There's not much of a graphical interface to it at all. There's some minimal windows, but that would be all you would get. So at least with RStudio, not only do you get the console window, but you get all of this other stuff too that's going to help you as we go along be able to manage the data, your code, your output, etc. And so one of the things you'll notice down here on the bottom right is there is a tab for files, which is basically being able to use the same thing as the File Explorer on your computer. What's it called in a Mac? File Explorer, reasonable? Finder? Okay, so it's like File Explorer or Finder. I need to start learning some Mac lingo. So I can be, what would that, bilingual, right? So there's a way to be able to see the files that are on your computer. Once we actually start generating some graphics, they'll show up here in the plots window. We're going to talk about packages in just a second. There is a help window here, and you can search for different things. In this case, right now it's just showing me the command if I wanted to calculate a mean using R. There's the command, just mean, and you put in the data set and it'll give you back the mean. So you can look up things here in the help window, and then there's also a viewer window, which we'll see a little bit later. The other thing to notice is up here at the very top, there's something called the environment. Right now our environment is empty, so we don't have any data, we don't have any other objects created. There's nothing in our current environment. We'll see how that works in a minute. The history tab here is a little bit like the log window, if you've ever looked at that in it's like in SAS or other computer programs. And it literally is right now. It's just a history of every command I've ever typed in, probably since I first installed this because I never clean it out. I'm not going to talk about connections. We won't worry about that. So just some basic pieces to the interface here to get a feel for it. We'll be talking through some of the different different menu options up here. We'll spend some time with different things that are available in the file. Editing is like it is in a lot of other programs. We won't do so much with coding. There is some viewing, and actually, thanks to Erin, I just figured this out this morning. If your text is really, really tiny on your screen, you can do the zoom in and zoom out to fix that. So I believe if you zoom in, I don't know if this is going to do anything on mine. I may be zoomed in all the way. If I zoom out, I think it makes it smaller. Anyway, so there's ways to change that back and forth. You can change how things look on your screen. Let's see. Plots, we'll talk about session. This, I'll point out a few things, but for the most part, if for some reason your R crashes, sometimes you can click Restart R, and it'll sort of refresh the program. There's some pros and cons to that, but just know that's available. I'm not going to talk about build or debug or profiling. Tools. So the tools and the help window, and let me just show you a few things in help. There are some cheat sheets, and there's a few of them listed here. Probably the one that you'll want to look at for this workshop will be the one that says R Markdown cheat sheet or the R Markdown reference guide. So as we go in the second part, we'll be talking about R Markdown. And there's also Markdown quick reference right here, which if you click on that, that brings it up in the help window. Okay. And all right, so packages. So when you install it, we've got R, which is the main language. We've installed RStudio, which is going to be the interface to that, and you have to have both of them on there. But then we need additional pieces because the basic R language only comes with some basic functionality. All the other functionality comes from packages. And probably the best analogy I had from somebody this past week that suggested, said, it's a lot like installing apps on your phone. Right? You want an app to track like how far you walk, you want an app to manage your checkbook, or you want an app to play a game. So these are things that you install. So to a certain extent, that's what we're doing here with installing these different packages. And for this workshop, we're going to work with 5 different packages that are out here. And so prior to the workshop, I'm going to send out instructions for everybody how to install those and test and make sure they're working on their computer. So each of these come right now, they're all published on CRAN, which is, or CRAN. And so this is where you went originally to download and install R for your computer, but you'll notice over here on the left under software, there's a link for packages. You can look at them by name, and right now there's over 12,000 packages published on CRAN. You can look at them by task view. If there's something you're looking for that has a specific kind of functionality, you could click on task view and say, like, maybe you're interested in economics. You could look at all the packages that have different things for finance and economics. If we look at them sorted by name, one of the ones that I listed was Tidyverse. So if I click on T and scroll down, we can actually find Tidyverse. Wherever it is, Tidyverse. And so here's the information. There's a little PDF. There's a vignette down here that with some examples of what Tidyverse is. And then there's also a link to the website for Tidyverse, which is tidyverse.tidyverse.org. So a lot of the packages that are out here, they have additional supporting materials and information. Okay, so how do you install it? And again, this will be part of the read ahead material, but that's in the tools window. If you click on Install Packages, Assuming that we actually have connectivity, you should be able to, through Wi-Fi, connect to the CRAN server and then download these. But again, I'm going to assume people have done that before they come into the workshop. Okay, so once these packages are installed, they're installed and they're now sitting on your computer. You still have to have a way to load them into memory and make them active. And the way we're going to do that is a couple of ways. First of all, if you click on your Packages tab, I'll make this a little bit bigger just so you can see it. This is a list of all of the R packages that you may have already installed on your computer. If you just installed it for the first time, you're only going to have a few. If you've been using it forever like me, you've got 1,000 different things installed on here. But if I scroll down, you can see that I've actually got Tidyverse installed down here. It'll tell me what version I'm running. In this case, it's 1.2.1. Your version may or may not be exactly the same. If I click on the little box, I can load it, and this will load it into memory. And it actually runs a command down here. Now, it went kind of fast with library tidyverse. So a little bit later on in some of the examples, you're going to see where I use the library command to load a package into memory so that then we can use all of the functions and everything inside that package. So, you know, it's kind of like, technically you could actually download an app to your phone, but if you didn't install it, you wouldn't be able to use it. So it's kind of like what we're doing here. We're sort of, the first step downloads everything to the computer, and then you have to run the library command to actually activate the functionality inside that package. The other thing to notice is that with Tidyverse, especially when I did that, a whole bunch of other packages lit up, TidyR, Tibble, some of the ones that are listed here. Specifically for the workshop, we're going to use ggplot2, which is a plotting package, and you're going to be using dplyr, which is a way to sort of manipulate data. The other thing you can do from the packages window is each of these things are hyperlinked. So if I click on Tidyverse, I get a help page for this Tidyverse package. And so I can get a description, there's a user guide, as well as other documentation, and then there's a list of all the different things you can do with the Tidyverse package. And so you can click on some of these and get different help support. All right, any questions? I know for you guys, y'all have already seen a lot of this with class. Okay, so let's get our feet wet using R. So let's create a project for this workshop. I've already got one on my computer, but I'm going to show you how to create one. So if you've already downloaded the zip file and unpacked it, as long as you know where that is on your computer, you can come in here and say, I want to create a new project. It'll take a minute. If you didn't have the data already downloaded and set up, you could actually go to a new directory. For now, just go to wherever you've already downloaded that data. So we'll be working with an existing directory. And we won't do it in this workshop, but if you were using GitHub and you had a live link to the GitHub account, you could actually use version control as well, but we're not going to do that for this. So if you click on existing directory, and then you just have to go find where it is on your computer. In my case, it's down here, and I actually have something set up for SNRS 2018. So just find where that is on your system and click Open, and then click Create Project. I'm not going to do that because I've already got a project created, but I just want you to see how to do that. So once you do that, and while y'all are doing that, I'm going to go ahead and open my project because I've already got it created. So once you've already got one created, then you just have to open it. All right, so once this opens, we'll actually be using RStudio, being able to look directly inside this directory. So I'll scroll this back over just so you guys can see it. So I'm now actually in this case, it's in my GitHub subdirectory, but I now am in the directory for the SNRS 2018 Reproducible Research Workshop. And so you've got all these folders that you can get access to with the data and the examples. So for now, click on Module 2, and you can click on the file here that says Module 2 R code. And I'm going to show you guys some stuff that you can do with R code to get started. All right. And so I've got some comments and things in here, which comments are just started with a hashtag, and that basically says, this is a comment, I'm not code, ignore me. And what I want you to try is, just to get started, type in some simple commands. And so I've got the commands up here, and I'm going to show you guys how to run those using the script file in a minute. But inside this console window, I can actually just use the console window almost like an online or as a calculator. So I can type in 1 + 1, it'll tell me the answer's 2. I can type in 2 with the little up arrow 3, that's like 2 raised to a power of 3, the answer's 8. Turns out there's some built-in stored. So today is what day? Pi day. It's too bad this isn't going to work for next week. So if I just type in pi, I get pi out to a few decimal places. I can type some commands. So I could actually say I want to take the log of 2.5. So I can use mathematical functions and stuff. And this is all fine and good, but not terribly exciting. I can do this with a calculator, right? Let's try a few more. So again, notice over here in the top right, it still says my environment is empty. So I actually really haven't created any data. I've created a little bit. Technically, these values are sort of kind of stored in memory temporarily. They're not really permanently stored. It's just temporary. As soon as I close out R, all this would go away. So really, I want stuff that I can store and keep. So to do that, I want to be able to assign data to an object. So think of this as like a bucket or some kind of container or folder that I'm putting data in, and essentially it's that data container that I'm going to use going forward. So if I type in 1 + 1, that answer, that result of 2, is going to be assigned to an object called A. And the assign character in R is > followed by a dash. You could technically use an equal sign, but that gets confusing for other reasons later on. The traditional way to do it is to use this assign character. So as soon as I do that, notice up here in my environment, I've now got a value called A, and its data point is 2. We can try a couple others. If I actually want to see what that looks like, I can just type A again, and it'll tell me, yes, A is 2. Here's a couple others. If I take A, which has a value of 2, and raise it to a power of 3, I'm going to get an answer 8. If I want to save that, I could assign it to a value called B, and to see that value of 8, I could call it back. So again, not terribly exciting, but at least now I've got some data. It's now still technically stored in temporary memory, but I can easily go back to it. I can just type in A and get 2, type in B and get 8. Let's try a few more. Type in these vectors and let's store them. So we're gonna create something called x1, x2, and x3. So x1 is just a series of numbers from 1 to 10, and the C function there with the parentheses says take these numbers and combine them or concatenate them into a vector. And so we're going to have these values here that go from 1 to 10. And just like I was typing stuff down here in the console, you can keep doing that, but since I've already provided you with the R code above, you can actually highlight these and just simply click Run. So it saves you the time of having to type everything in the console window. So anything you're trying to do in the console is, I think, always better to do inside of an R script, which is really basically just a text file, but the underlying R code or R software that you installed knows how to interpret that text as R code, and it does stuff with it. And so I can actually now highlight all of these and click Run. And I've now created, I'm going to open this just a little bit bigger so you can guys see it. So I've now got 5 objects in my environment. I've got A and B, X1, X2, and X3. And you'll notice that X1, X2, and X3 are all 10 elements long. They're all numbers. I can do stuff with these. So I could actually take these and make a plot. So here's a plot. This is a little sine wave because X3 is just the sine of X. And I'm plotting these. I'm type B here. That's an option for the plot command. So that I'm going to have both lines and points. So it's giving me both. And then I'm coloring it using blue. So these are just options that I'm putting in. The first value, X1, is the X-axis. X3 is the Y-axis. So you're getting a chance to sort of see, and here's a plot. I could add colors. So suppose I've now got something that has 10 elements, and they're all different colors. And since red, blue, and green here is text, I'm delineating it as text by putting double quotation marks around each word. So you'll notice when I create X4, it says CHR instead of num, so it's not a number, it's a character vector. So, and again, it's 10 elements long. The thing to note here, and how many of you guys, pretty much everybody, has used SAS or SPSS, even Excel, right? We don't have, in this case, let's say I had these 4 objects. I'm not going to normally have those in 4 separate Excel files. I'm not going to have them in 4 separate SAS data sets. They're all going to be inside the same data set, right? So this is kind of the pro and the con of R. In R, I can keep all of these things completely separate from one another. They do not have to be combined together in the same data container, the same data object. These are now 4 independent objects. Notice that I'm using them in a plot command. I could use them inside a regression command. I could actually mix and match things. That's a huge amount of flexibility, and it can get really confusing really fast. So we'll put these things together. Oh, and here's just one more example of the plot command. This time, instead of specifying a single color blue, I'm actually pulling the colors from X4, and now if I just run that plot command, I get slightly different colors for each of my data points down there on the bottom. But in reality, for most of what we're going to be doing, all of this data will be combined together in a data frame. And we can create a data frame this way by putting these things together. And it works really well because everything here has 10 elements. So I can combine these together. And now you'll notice up here in the environment, I have something that says DF. If I click the little blue arrow, I can see I've got these 4 different columns. And there's a little table icon here. If I click on that, I can view my data. So at this point now, we're kind of back to where we probably originally thought we'd start, which is with something that kind of looks like a spreadsheet. All right. We can view the data frame. There's ways to select data. For the purposes of what you guys already know, you kind of know this piece, so I'm going to skip ahead a little bit, but I'll just show you what's in here. This just talks about data selection so people can understand how to find different pieces. Look at the names of the variables in the data set using the names command. This is the one that I'll probably show them is how to select a column out of a data set using the $sign. And then basically how to do that same plot command, except now the data is inside the data frame, and it changes a little bit because I have to say, okay, I'm using data frame first column, data frame third column, the data frame with the 4th column. And so I have to get sort of specific. And I'm going to skip this part 2 for you guys today, simply because I want to get to the next piece. Show them how to load the tidyverse package, and then use the dplyr approach here for selecting a variable and then making just a simple plot using ggplot. So just to show you guys what this looks like. You get a similar plot, but it's, oh, okay, I thought I had loaded tidyverse. Let's try it again. I guess I hadn't loaded it. I think I restarted my session. Maybe that was it. Anyway, so same kind of plot. It looks slightly different, but anyway. Okay, so for the purposes of what the people at SNRS, I'll go through this part a little bit longer, but for y'all, I'm cutting it short. All right, so the idea is just to kind of get them used to the idea of what an object is, how to select data out of a data frame, and so forth. Okay, so this is just a really bare bones basics of how R works. I'm making a note here for some help sources. Okay. So skip Module 3 for right now. Let's go to Module 4. Module 3 actually kind of got merged with what I was doing there in Module 2. I'm going to have to separate that out a little bit. All right, so let's take a look really quick and get an idea for what R Markdown is. And I'm going to have you guys look at the files that I've created here in just a minute. But up here at the top, click on File, New File, R Markdown. And for those of you that just installed RStudio, the first time you do this, it may say that you need to install additional packages. And I'm going to try to put this in the read ahead video about that. Anyway, so if it asks you to do that, just go ahead and do that. Let's just create a basic file, and we can just say first R Markdown document and type in your name or whatever, however you want the author to see. For right now, we'll just use the default format of HTML. You could do Microsoft Word as an option. You can also do PDF, and I'm going to have a little optional video on how to get set up. You have to actually have a LaTeX package installed on your computer for the PDF piece to work. But for right now, just choose HTML and click OK. So one of the things that the developers of RStudio has done is they've actually got a built-in default template that you can do right out of the gun, or right out of the box, that you don't have to know anything, and you've now got this great template. So let me show you some of the pieces. At the top is something called YAML, which is basically just a header. So it has our title, the author, the date, and the output format. So as long as you have those pieces, you're good to go. This next little piece where you see 3 backticks followed by the curly bracket with R, this says this is an R code chunk, and what follows are some R commands. For right now, we're just going to leave that alone. This is it's setting up some options in Knitter, which is the thing that compiles the final document. You'll see that in a minute. And where it says echo equals true, what that really says is, go ahead and show me all of the code in my final document. If we set echo equal to false, it would hide the code and you would just see the document, but the code's still there. So, so just know that that's kind of how that's working. So we're going to skip that piece for right now. So the next part that you see is Markdown. So how many of you guys have ever gone to a web page and right-clicked and looked at View Source? You ever done that? We'll take half a second. I'll show you. All right. So like here's a web page, right? If I right-click and say View Page Source, there's the HTML for the web page. So a browser software looks at this code, which is HTML, which stands for Hypertext Markup Language, and knows how to read that code and display this web page. Now, there's a lot more going on under the hood, but that's HTML. So it's Hypertext Markup Language. It turns out Markdown is a simplified version of HTML, and it has a lot less coding type stuff going on. And it turns out you can actually mix and match Markdown with HTML, and I think maybe even a little XML code. So a few things here. It's just really sort of how you mark up or mark down the text. So if I type in the word here, R followed by Markdown, it's just text. It wouldn't be any different than typing in Notepad or some other basic text editor. But as soon as I put these 2 hashtags in front of it, notice that one, it changed to a blue color. The hashtags here are an indication of a header. So I'm now going to get a header level 2 because I have 2 hashtags. And you get a chance to sort of start putting in the formatting as you go. But for the most part, this is all just plain text. The R Markdown compiler, which in this case is Knitter, knows how to interpret that and then reformat the text on the fly. And to see this, if you go to Tools and go to the Markdown Quick Reference, here's a quick summary of some of the things that you can do. So if I want to emphasize a word, if I want to make it italic or bold, so you'll notice that the word knit here on either side of it with no spaces has 2 asterisks in the front, 2 asterisks at the back. It's going to make that word bold. I could do the same thing by putting 2 underscores before it and after it. If I did a single asterisk or a single underscore, it would make it italics. Don't ask me how to do underline. For right now, we're just going to do italics and bold. Turns out this is actually a hyperlink, and they've offset it using the little carets on either side. There's another way to do that. I'm going to skip this R code chunk for right now. There's one more little bit of markup here that you'll see in this default template, which is we've got a backtick here at the beginning and the end. Excuse me, beginning and end of echo equals false. And what that's going to do is turn that text into, go from proportional to non-proportional. It basically will look like it came off of a typewriter. Okay, so this is a heading, and here's some more information on headers. You can do lists, which we'll see in an example here in a minute. Line breaks, you can have hypertext links, you can link to images, you can have block quotes. We'll talk a little bit about the R code as we go. You can show plain text. There's ways to do inline code. You can do equations and so forth. And we'll show a couple of quick examples of tables later on. All right. So this file is basically, it's got some header information. We've got 3 sections. A section here says R Markdown. One on plots. I guess that was it, just 2 sections, R Markdown and plots. And we've got 3 R code chunks. This first one just sets up some stuff for the document. It says, do you want to show or hide your code? This one runs the summary command of the built-in CARS data set. So to see that, if you're in this console window, you can see what this is going to do. If we type in the summary command followed by CARS, make this just a little bit bigger so you can see it. It gives me some summary statistics. Turns out the CARS data set is built into R, so you don't have to already load it. It actually comes with base R. And so there's 2 variables in there, speed and distance. And you can see the min and the max. It gives me the mean and the median for speed and distance. And I think speed here is, I can't remember if it's miles per hour, kilometers per hour, and then I think the distance is feet. And then there's another R code chunk down here that makes a plot of another data set, which is the pressure data set. And so if I just put that in the console window, we should end up with a plot. So in my document, I'm going to have it like some headers. I'm going to have some text. I've got a little bit of like formatting going on, and I've got these 3 R code chunks that I'll see the results of, the summary statistics and the plot. So go ahead and save this, and you can just call it your first Markdown. Just give it a name. Click Save. So let's make it into a document. We chose HTML as the default, but if I click the little arrow next to the knit button, I could still change that if I wanted to. But for right now, click knit to HTML. So it's actually going to now take these built-in data sets, CARS and pressure, plus the code that you just saw, plus the documentation, and write a report. So here's your first R Markdown document, and it shows up in this viewer window. So here's my header, here's my hyperlink, the word knit is in bold, here's the summary of the CARS data set, and here's the plot. So did that work for everybody? You guys have already mostly done this before. All right. So depending on where we are in the workshop, I may let people just play with it for a little bit. But here in what you downloaded from the course materials for Module 4, if you click on the file that says Module 4 R Markdown Example, you can come in here and you can change the title and the author date if you want to. but play with this a little bit. So this has some examples of different levels of headers. There's a couple of more ways to put in hypertext links to web files. So like if I wanted a link to Google, this is another way to do it. Word in bold and italics. Here's some plain text. It's just, notice this doesn't have an R after it. This just says, set this off as plain text. Here's an example of a non-numbered list. Here's an example of a numbered list. Block quotes, you offset with little greater than signs, and it'll show up as a quote in the final document. You can nest those. You can also have code inside of that. This is the example you just saw with the summary of the CARS data set and the plot. Tables. So I'm not going to spend a lot of time on this, but I just want you guys to see it. So the knitter package, which is really what's happening when it compiles this document, has some other functions built into it, one of which is the cable function, and that allows you to make some nice looking tables. So it turns out in R, there's a function called head. So if I just wanted to see the top few rows, in this case the top 6 rows of the CARS data set, I could say, give me the head of the CARS data set. So if you kind of want to see what that looks like, you can just run that R command by itself. Here's the raw data. But it'd be nice if we could format this as a pretty table as opposed to it just being a bunch of text output in our document. Well, that's what the cable function does. And so it's going to turn that into a nice table and give us a caption. For those of you that may be interested, you have to learn a little bit of LaTeX to do this, but you can insert equations using LaTeX math. There's just a simple example of a regression equation. We can insert images. So when I distribute this, and I don't, this is probably going to break because I haven't fixed this yet, so I need to make a note on the insert image here. This assumes that this file called sunstar.png is in this directory, so when we go to knit, it's going to give me an error. I'll have to comment that out. I've got some other things too where you can insert animated GIFs and videos, so I'll have to do that one next later. You can also insert footnotes. And there's some ways to do that here with the syntax, and I just encourage you to read a little bit more on how to do that, especially for those of you that are working on your projects in 741. You may want to look into that a little bit more. It's kind of nice to do. So I'm not going to try to knit this because it's going to break on me. So we're going to skip. Well, here, I tell you what. Actually, let's do this. All right. If you want to try to compile this, I'm going to delete this section about the inserting the images for right now. The rest of it should work, but if you want to try knitting it, just delete that section. All right. So if I click knit to HTML, we'll see if this works. So here's what the file looks like. Here's the different level headers. Here are my links, bold, italics. Here's just some plain text. It's offset. Here's the non-numbered list. Here's the numbered list. Here's an example of a block quote. Here's one that's nested. Here's code that's nested inside of a block quote. You already saw the summary and the plot. There's another thing here, and I sort of skipped over it. Let me see. Let me go back to where I had the plot. Okay. So in this first one, this is just sort of the default. I actually had another little code chunk here, and it had the pressure data set. You'll notice that I have echo equals true, but then I changed the figure height and figure width. I changed it to 4 by 4. It turns out the default, I think, is 4 by 6. Or it could be 5 by 7. I'll have to look that up. But this was the default plot, and then when I did it again, I made it a little bit smaller. And all of these little things inside here are options that tell me that, okay, I'm running the code. When I'm done, is there something special I want done with whatever's inside that R code, specifically, in this case, an image, something different I want done with it in the final document. And so the options are these chunk options that are inside the curly brackets. So pressure 2 is just a name for that R code chunk, which is helpful when you're debugging later on. It's always a good idea to like give it a little name like setup, you know, data check 1, regression model 1, whatever. Echo equals true just means I'm going to show the code. But the figure height and width here, I can either type those in, or it turns out, see this little gear icon? If you highlight and just leave your mouse there, it says modify chunk options. If you click on that, I can come in here, I could actually change the name of this little code chunk. I can change all of the options here for warnings. I can change the output. But specifically where it says width and height, I could actually change this to 5 by 5 and click apply. And it automatically changes the code shown here. And if I re-knit this document, that plot's going to be a little bit bigger this next time. And so now my plot's just a little bit bigger. So it's kind of a handy way to get in here. And again, this is why you want this IDE, why you want the RStudio interface, because it gives you all these nice little places where you can go in and tweak your document, change formatting, and so forth. Okay. Any questions on that? I encourage you guys to take this document, hack on it a little bit more. All right, so those are some of the basics. So again, we've got this idea where we've got data plus code plus the document. It all lives together and it all works together. So in the workshop, I'm going to skip it for you guys, but in the workshop, I'm actually going to also show them how to, instead of knitting to HTML, we'll knit to Word. I'll give them an example if we have time to do a knit to PDF. And it turns out, when we created that first R Markdown file, I glossed over this, but in addition to document formats, there are presentation formats. So PowerPoint slides, although we're not going to do PowerPoint, but those kind of slides. There's something in here called Shiny, which we won't talk about, and we probably won't get a chance to go through templates either. But in presentation, type in something like my first presentation. And there's 3 different formats in here that you can use. There's IO Slides, Slidey, and Beamer. Beamer's a PDF, so for right now we won't look at that. But let's take a look at IO Slides. IO Slides and Slidey are both HTML, meaning these are slide formats that you can use in a browser window. So if we click on IO Slides and click OK. So again, it looks very, very similar to what we did with the document. There's some information at the top in the header with the title, author, date. It tells me what kind of output it is. There's a little chunk option to set it up there. For right now, it's hiding all the code. It says echo equals false. This time, this is still kind of a header, but in a slide format, the 2 hashtags there, that R Markdown, becomes the title of my first slide. And everything under that is the content that's shown on that slide. So I'll get a slide here for R Markdown. I'll get a slide with some bullets. Then it'll say slide with bullets. There'll be a third slide, slide with R output, and slide with plot. So try that and click knit to IO Slides and see if you get the slides. Oh, and it's going to ask you to save it. So let's see, first presentation. And we'll click save. Yes, but it's online. I'll show you here in just a second. For right now, it's a little hard to see, probably because I'm zoomed out too much. If I click open in browser, it should just open in whatever your browser window is. So remember the slides that I was showing you before? This is exactly how I created them. So you get a title slide. Here's my first slide that tells me something about R Markdown, slide with bullets, slide with some R output, the summary of the CARS data set, and then the plot. So let me close that. And yes, so it turns out if you just go to the RStudio, or actually I tell you what, if you Google R Markdown, it'll take you to this web page for everything about R Markdown at rstudio.com. And there's a whole set of good information here on getting started. There's a gallery if you just want to see some examples of different kinds of documents and things that you can do. But under formats specifically, you can actually click on each of these formats. So if you click on IO slides, here's everything. Like it gives you stuff on how to do bullets, code appearance, tables, layout, presenting, themes, all kinds of cool stuff. So good question.
We should do this for our project, right?
You can. I will say this for those of you in 741, give it a shot. But if you want to use PowerPoint, it's totally fine. So it doesn't, you don't have to be hamstrung. Same thing with tables. If you can't figure out how to make the table inside R, don't worry about it. Just get the output, make the table, and you know, because the tables are still really, really hard. They just are. The slides aren't bad though, huh? Yes, and I'm looking at poor Gia back here. She did a fantastic job, gave it a shot last semester, and came really, really close to getting it to work. And Table 1, there actually is a package out there called Table 1. It's kind of hard to get everything set up all at once. So, but man, you gave it a fantastic try. So. That's okay. If we have time in the class, and we won't have time today, there is a package out here called Reveal.js, which actually has some kind of cool slides associated with it. I don't think I have everything set up, but if we have time when I do this, I'm on the fence as to whether I'm going to include this next week or not. But if you guys had installed the Reveal.js package, which I'm going to keep my fingers crossed, we'll see if this works. If I click knit to Reveal.js, I will actually get the slides here in that format. And so if I click open in browser, here you can get a chance to see what this looks like. It has all these sort of funky dynamic transitions and colors and themes and so forth. So there's a lot of really neat things like that you can do, and you can kind of play with it here on the screen too. Okay, so go to Module 5. All right, so we're going to get a chance to play with one of the data sets from the 538 package. And I'm still working on cleaning this up. Go to the one that says stakescript.r. And I'm going to scroll up here to the top. Okay. So we're going to specifically be using these packages, and their package is already loaded, but I specifically went ahead and listed it here just so that, because there's some stuff I'm doing with tables later on. So this is all of the code that I'm going to use in this article that I'm writing based on stake preferences in the United States. So I can show you this real quick. If I click on, excuse me, packages, oops, and click on the help for 538, which is the package where this data set's coming from. If I click on S, here's the stake survey. So this is the information on the data set that we're going to play with here. So the raw data behind the story, how Americans like their steak. And if you want to read the article, you can click on it here and take a look at, it's looking at things of different regions of the country and how people like their steak, well, medium rare, and so forth. There's also some other interesting information in here on, there were some things about, like, if you liked your steak more rare, it's kind of like, were you more likely to bet on the lottery, I guess. Anyway, it's an interesting article. So you can take a look at that. It gives you some information. So this is another built-in data set, right? So we've looked at the cars and the pressure data set. Well, it turns out when you install 538, it comes with all of these other data sets that you can play with too. And so this particular data set has 550 rows representing all the different people that responded to the survey and 15 variables. And so the variables inside of here are respondent ID, whether or not they like the lottery, do they smoke, are they a drinker, do they gamble, do they skydive, speed, cheating. It's basically risk-taking, right? Looking at, and then how they like their steak, the gender, age, household income, education, and the region of the United States. Okay, so we're going to load these packages, and I'll just run through this real quick so you guys can see the pieces. the data set I can actually load using this data command. And you can't quite see it here in the environment, but it's now kind of loaded in memory temporarily. And earlier, I will have talked a little bit more about dplyr, but for right now, I'm not going to probably delve too much into all of the code. I just want you to know this code's available, and then we're going to insert it inside of a document. So one of the first things I do is subset the stake data set, and I'm going to look at a specific region, in this case, the mountain region. And so that's what this step is doing, and it's leaving out, it's also stripping out some missing data. That's what this NA omit command is doing. And so I create this little subset here, and then I'm going to take and use some commands here. I'm just going to scroll down so you can see all the pieces. So this next little section is sort of 3 pieces of code that creates a table of the different age categories, converts it to a data frame because I have to have it in a data frame format for the cable function to work. So without going into all the whys and wherefores of how all this code works, just know it does. But basically, I'm taking this table and I'm adding some labels, some column names there, and I'm giving it a caption. And then it turns out that Cable Extra package that I asked you guys to install gives me some options here to make the table look just a little bit nicer on the page. So it's not like spread out as wide as the whole web page. It's a little more contained. And so basically this sets up a table of the age categories. And it turns out I'm going to repeat that a couple of times. I can do it again and get a list of the education, a list of household income. I'm going to skip the optional thing right now. And then down here at the very bottom, oh no, sorry, skip that. It's going to be a plot. And we'll come back and talk a little bit about this, maybe not in this class, but in the workshop I will. But I'm using the ggplot environment to create a plot that's basically going to be the different stake preferences that you saw in the 538 article. In this case, I'm breaking it down by gender. And so I'm actually, where it says fill equals female, we'll actually be able to see the stake preferences by gender, again, for the mountain region. So that's all of the code. Click on the stake article.rmd. So this is the R markdown file for creating this report. And you guys, I may go back and change some of this. I'll change some of the date. If you ever want to actually pull a live date, this is actually the R code to do that. I think I may go back and take this piece out for the workshop just because this part gets complicated. But I've got a title. It turns out I can also have a subtitle. So that's one thing we can always add in our header. Author and date. In this case, I'm going to stick with the HTML document. There's a little bit more information and stuff going on here in this first code chunk that sets up some stuff. Basically, I'm hiding the code, echoes false. I'm also turning off warnings and messages. It just cleans it up so that my report doesn't have a lot of ancillary, like log commands in there. It's also getting rid of the missing data and just setting it to a blank symbol for tables. It just sort of cleans up the output. I have to load all of my R packages, and somebody's probably going to ask me, well, wait, didn't we just load them? Yes, you did. But it turns out when you create a document like this and you go to click knit, the first thing knit does is clears and restarts your R session and cleans out your environment. You won't see it happen on the computer. It's happening in like temporary memory. And so it starts with sort of a vanilla system and then creates the document. So just because you have stuff in your environment and just because you've loaded that package, you know, while you were sort of interactively working, as soon as you go to knit, it creates a brand new clean environment to create the document. And that seems like a waste of time and it's redundant, but it makes a lot of sense because suppose I was doing something on my computer and then I handed the file to Gia. Gia's got a completely different environment. So it would be nice that when we both create the document, we're starting with the same basic clean system. And so that's why Knitter cleans everything out. So we do have to reload all of those packages, and that's something you have to do at the beginning of every document. Whatever functionality that document requires, you have to load the packages to start with. And then the rest of this is just the code that I just showed you. So we're loading in the data set, we're creating a subset. This is already here for you, but this is some background that I typed in based on that original stake article. The purpose, this describes just some summaries of what was there that 538 did originally. And then the tables. And so that's what this next part is. So I have the table code for creating, looking at the ages, the education, and the income levels. And I'm going to probably go back and take out this optional table, so just ignore that for right now because that gets complicated. And then I've got the plot. So if you've got the 538 package and all those other packages installed, click on knit to HTML and we'll see if this works. Yay! All right, I'm going to give you guys a minute and see if that works. For those of you following along live, did it work? Yes. Okay. So we've now got something that looks halfway decent. And I'm going to talk about the mountain piece here in just a second. There's a reason I've got mountain highlighted in bold. So I've got the title, my subtitle, author, date, background, purpose. Here are my tables. And so that cable extra package that I added, if I hadn't done that, my ages would take up the whole width of the screen. By putting in the cable extra, it tells it basically to compress the table and make it a little bit neater to look at. So here's a summary of the different age categories, the education levels, and the income levels of these different survey respondents. We'll skip the optional table for now. I'm going to take that out. And here's my plot. The one thing I'll point out here at the end is at the very, very end, one of the packages I had you guys install was GG themes. The last line of that GG plot command says theme 538. There actually is a graphical theme based on what the guys at 538.com typically publish. So this is kind of like their graphic format. And so you get a chance to make a plot that may or may not look like some of the previously published plots at 538. It might not look exactly like they do now since ESPN bought them, so they probably have a whole other formatting template at this point, but some of the older articles may have stuff that looks like this. So hopefully you're getting a chance to get a feel for how these pieces work together. And I know we're not going to get a chance to really get under the hood on all of the code that you have here, but at least you'll walk away with some code that you can play with and tweak. So one of the first tweaks that we're going to make is if we go back over here to Files, and let's see, let's go to Module 6. And I think we're only going to have time for me to maybe, well, I can show you two things. Okay, so if I take this basic stake article, right? So I've now got this template with all this stuff in it. And notice that I have the word mountain highlighted here. So I've got mountain region specified in the title. I'm filtering, right, because I'm just looking at the mountain region. So I've put mountain in here. I mentioned it a couple of times in the purpose. And I think there's one more place. Let's see, I think it's down here in the plot. Let's skip that. Where I've got the word mountain here, and then I think I also specify the mountain region. I was trying to think. Oh, okay, it's listed here as mountain. Okay, so it turns out in that data set, so I'm gonna just grab the data set here just so you guys can see it. So I'm just really quickly, I'm just going to stick this in my environment so you guys can see it. So did that work? Where'd it go? Oh, I did it wrong. Boogers. How do I do that? Okay, let's see. All right, sorry. So just to show you here, this is kind of what the data set looks like, the respondent IDs. Most things that are in here is like true and false, that they say yes or no, stake, prep, household income, education. And then finally, there's this column at the very, very end for region. And if I actually do a summary of stake survey and just look at that region variable, okay, hold on, table. Sorry. Okay. If I use the table command, now I can get a list. So there's 9 regions, 1, 2, 3, 4, 5, 6, 7, 8. So there's 9 regions, tells you how many respondents we had from each region. At the moment, I've got my report writing for mountain. What if I want to change that? So here in Module 6, if I click on the one that says Stake Article Params, this is the same exact R Markdown file that you have there, but notice I've added a piece here in the header, and it says params. And then under that, I've specifically said I want to set region equal to Pacific. So I've now got the ability to use a parameter that I define in my header that will update the content in the rest of the document. So that's the first change that I had to make. The other changes are a couple places where I mention the region. So back up here in the subtitle, I changed out the word mountain for a little tiny piece of R code. So it turns out inline R code is, instead of the 3 back, like with our code chunk, you have 3 backticks and then there's a whole section of R code. If you just have a little small piece of R code and you want it inline, you just do 1 backtick R followed by whatever the R command is and another backtick. And you can actually stick R code inside of a sentence. So in this case, all it's saying is take the params object, and I'm selecting specifically region. So whatever I type in here, it's going to put that word up here. So if I change this to Pacific, it's going to say summary report for the Pacific region. And I do that a couple of other places. So remember, we did that. I said I mentioned the mountain region and the purpose. So I made the substitution here and here. There really wasn't anything in the tables. So again, you see it down here in the plot. So there's the other change that I made. And then there's a piece here in the title where I swapped it out there. So there's really just sort of 4, maybe 5 places where now instead of having the word mountain, so I've made an explicit specification of the region, now I've got basically a variable for region. So go ahead and try to knit this document. And for the most part, it should look almost identical to what we did before, except now it will be stake preferences for the Pacific region. So when this finishes, you should get something that looks like this. The makeup of the respondents are going to look a little bit different because obviously these should be different respondents than what we had in the mountain region. I'll skip the optional table. I'll take that out later. And here's the plot. So let's try another one. So there's 9 regions here. Pick another one. Let's try New England. So if I take New England and back up here at the top, I don't have to change anything else in the report except this one spot. So if I change that from Pacific to New England and click knit, I should get a whole brand new report for the New England region. Ta-da! Any of you guys watched Deception the other night? It was on the magician that works with the FBI. I'll just tell you right now, I think this is ABC's answer to canceling Castle, because in the first episode in the pilot, any of you guys ever watch Castle? I was like, okay, I'm sorry. I was religious about watching Castle. I love that show. I'm a huge Nathan Fillion fan. Firefly. Okay, I'm a geek. Anyway, sorry. But in that, every time he finished a trick, he would go, ta-da! Okay, I'm sorry. Anyway, so you can see how fantastic this is. And just to wrap it up, turns out there's actually some ways to make this even easier so that we don't have to keep typing this in, right? I mean, not only, it's great that we've automated the report and we can just change out this one parameter and it rewrites the whole report, but wouldn't it be nice if I had access to all 9 and I didn't have to remember exactly how to spell them, you know, and make sure I don't put a typo in here when I define the report parameter? Turns out you can actually do that, and you can use a list. So this next piece here, if you click on stake article params list, it's going to look very, very similar. Everything's the same. We've just now added a whole bunch of stuff to this params option in the header. So now we've got output, and then it says params region, and then under region, I've got these additional things. I've got a label that says these are the list of regions. The value, that value by default, it's going to pick mountain first, but I'm going to be able to change that. You'll see how in a second. Turns out it's using an input command called select, and then I have to give it a list of choices. And the way you list those choices is between square brackets, and then each option is offset with double quotation marks separated by a comma. Turns out that piece, remember back at the beginning I said, you know, we're creating different our documents. One of the options was shiny. This is going to give you a little tiny taste of shiny without actually having to write shiny code. So yay! It's a way to build sort of these interactive interfaces is really what shiny does. And so really what we're writing here is a little tiny sliver of shiny code. So in this document, now when we go to click knit, we're not going to knit to HTML. If we click knit to HTML, it's just going to go with that original default for mountain region, and we would just get the mountain region report again. But it turns out I can click knit with parameters. And if you click knit with parameters, it opens, it's now actually running shiny inside RStudio, and guess what? I've now got a pull down list. So I've defined my region box, it's a select input, and there's a list. So now I can scroll through here, maybe I want to look at the South Atlantic. When I do that and click knit, on the fly, it now knows that I've changed that parameter for our region parameter to the South Atlantic, and here's my report. I think that's where I'm going to stop. I don't think I can cram anything else in 3 hours, and I'm even sort of shortchanging you guys because I've got to run here in a minute. So, all right. Knit to parameters, knit with parameters. And so, so I could do it again, click knit with parameters, and pick a different region, maybe East, North, Central, and click knit. And the one thing, and I actually do this in my Coursera course, I'm not going to have time to do it at SNRS, you can actually write code that will run this in batch. You guys may have heard me talk about the per package. Turns out you can map, I can actually send it the list of parameters, the report template, and click run, and it will run all 9 reports for every region. So that's pretty awesome, isn't it? So, questions, comments? All right. While you guys are absorbing and talking, I'm going to shut down and save everything. Sorry. Yes.
Under line 8, when you write region, is that how it knows to look in the region column?
Yes. So that region for line 8, that's a variable in the original stake data set. Params is that's actually a header. Part of the header. So if you're knitting with parameters, it's going to go and look for that code word and then look for anything under there. So really under params, and I could have multiple, like I could have region, I could have age, and I could have gender. I mean, I could actually list a whole bunch of stuff. So you can get kind of complicated with this. All right, let me exit out. All right.